Hey guys, MiracleMAX here. Whew, boy is it hot here. I've just been outside doing some wiring on a car out in the open in the stinking hot, so I'm quite happy to be inside the lab where it's a lot cooler. Today what we're looking at is a Citroen C5 heater resistor block. It's not working. I know this is the fault because the customer has replaced it with another one, so I'm going to try and get this up and running and use it as a or he can use it as a spare. So let's have a look at it together. Bit squishy in my lab here at the moment. I've got amplifiers over to the right of me that I'm repairing. I've got tablets over to the left of me that I'm repairing. So I've got this little space here that I can work on today. So let's have a look at this. This particular resistor block is called a Smart Sense because of the circuitry inside. It is computer controlled. So to disassemble the thing, it's just a matter of undoing all these little tabs on the side, and once they're apart we can have a look at it. We can see it's got its circuitry inside, quite complex inside, as you can see. It's got a large MOSFET here, and that typically plays up. But there's a few other faults that I've found with this, and I'll get in close and explain what I've found. I'm not sure if you can see what I can see, but it's a little bit difficult to get this right because I'm just looking into the camera screen. But if we have a look, the terminal itself is actually sucked right down into the solder. So this thing must have got super hot at some stage and been enough to melt those two solder terminals. Obviously they're going to get resoldered, but I thought you might just like to have a look and see how badly affected they were by a poor connection. I've just got this under my digital microscope at the moment, and what I'm looking at is those two big terminals right there. You can see them. And these are the actual fan motor terminals. They're quite big in comparison to the others. These are got cold solder joints, and that is partially the reason that it's not working. If we turn it over, and I'll try and focus on those terminals, you can see for a start there's a colour difference between them, can't you? So see these ones in the centre here, they're quite shiny. These fellas over here are quite dull, aren't they? And in actual fact, if you have a look at this fella over here, that one there, it is actually out of line. So it's come loose, that's the problem. The reason that it's come loose and that those two terminals are grey in colour is because it's probably had a poor contact at some stage and created a high current draw. That high current draw in turn has, in actual fact, melted the solder on these two joints on the other side. From what I've read so far, also the MOSFET over this side, which is this big fella in here, which is an N-channel MOSFET, they also play up as well. So I'm going to check that and make sure that that's okay. Most electronic components are best tested off board, particularly with things like MOSFETs, etc. You can get wrong readings, especially if you don't have power running through the board. Of course, if you're doing testing with voltage running through it, that's different. But in this particular case, it's best to desolder it, which I'm going to do. Also need to remove this clamp which holds the MOSFET against this massive heatsink. So if it's got the size of this heatsink on it, it's rated at 110 amps. So it's actually really, it takes a lot of current going through it, and that is the reason for the huge heatsink on it. So I'll remove the MOSFET and then we can do some testing. Now got the MOSFET off the board. One thing I have noticed, even on the board here itself, I'm not sure if you can see it there, but see that little dark mark there? And if we have a look at the MOSFET itself, you can see that as plain as day. There's quite a dark circle right under the screw there. Now this may be an indication that it's faulty and it's collapsed or burnt out inside. There's certainly been some high current passed through this. So it's quite easy to see how it's been melted in through here. Even this plastic clip has been melted. But in particular, these motor terminals are the ones that are causing the issue. We lean them up here, see if I can get that into the frame. You can see the terminals themselves, or the connectors, have actually dropped down flush. That's how much heat has been going through it. So what I plan to do is just undo all of these here, pull it out, clean up those terminals, particularly in this area here. We're focused. In through here you can see that they're actually darkened in comparison to the other two. It's had very, very high current draw going through it, and I want to make sure that they're in good condition before we assemble them and before I put on my MOSFET there. Here's an indication. I've got the connector out now, and here's an indication of how much heat must have been going through that particular connector at a given time. You have a look at the length of the terminals coming out. See how short this one is, and that's because of heat. It's actually pulled out of the connector because too much current was going through, creating heat, and has just melted the solder and pulled back. So I'll pull those two out in particular, tidy them up, and then put them back in the connector and resolder them. Now check them out. Look how dark they are. They've certainly had some current running through them. They would have been arcing internally between the male and female section, and that would have melted the solder, of course. Would have been heaps and heaps of heat and current going through there. Time to tidy them up, straighten them up, resolder them, and MOSFET next. Well, it's nothing to write home about. The terminals are a lot better. The solder has come through okay. These connectors that were pushed through before, I've tidied up on the other side as best as I can. I didn't have any to replace them with, so I've cleaned them up and stuck them through, given them a bit of solder, a bit of alcohol, tidy up, job's done. What I'm going to tell the customer is, though, over here, of course, where they come through, obviously the female section of the terminal may be a problem as well. They may be burnt, so they may have to be replaced before this can be connected. So that's that side of it done. Now onto our MOSFET. Just need to clean up all that thermal compound, make sure that we get rid of all that before we put the new thermal compound on. And you can see that little black dot where is an indication where there's been excessive heat. The MOSFET that came out of this was a 55 volt 75 amp, but because these things suffer from so much heat and current draw, I've decided to put in a 55 volt and 110 amp, so that's a bit more beefy, and that should handle the heat and the current that's going through it. So I'm not sure you could call it thermal paste, it was more like thermal concrete. I had to scrape it off as best as I can with this tool that I use for phone screen replacement, and you can see what it's like. It's just like concrete and powder. So this thing was seriously overheated and therefore turned the thermal paste hard, which certainly wouldn't have helped with heat conductivity. It might seem like there's a lot of thermal paste on there, and certainly there is, but it's better that you put on more thermal paste. You can always wipe it off afterwards if necessary, but that's going to give good conductivity to our heatsink. You can see the size of the heatsink. She is massive, alright? So there's an indicator of how much heat is being produced by this thing. But hopefully, this being a modified one, or 110 amp, it's a bit bigger and beefier than our last one. It should be able to conduct the current better than the last one, and therefore produce less heat, and therefore create less of a problem next time, so it won't burn out. Time to solder it together. Just to give you an idea about thermal contact, when I was trying to solder in this MOSFET, it just, particularly the center leg, did not want to solder. I was not getting enough heat in there. Then I realized, hang on, it's hanging onto a huge massive heat sink. So I ended up having to pull it away from the heat sink to get enough heat into it to actually solder it, so then I could solder the legs there. But it just shows the efficiency of these heat sinks and the importance of good thermal contact by using a thermal paste or something similar. So she's all done. I just got to clip that back into place like that, and job's done. I do have to let the customer know that we really need to check out these connectors down here and make sure that they're in good nick on the female side, or the car side of this module here. So I'll assemble it, hand it back to him, and hopefully it's all good. There's another repair done. The problem with these Citroen heater block resistor modules is the fact that the MOSFET fails on them, plus also too much current goes through the motor, perhaps due to a blocked pollen filter or a fault with the motor themselves. So I'm going to have to make sure that the customer realizes that further checking is required with regard to the vehicle itself, not necessarily the module. Once he plugs it in, if the pollen filter is okay and the motor, the fan motor, is okay, this should kick in no problems. And it's been modified with that 110 amp MOSFET, so it should go for a lot longer. Sorry to interrupt. I have spoken to the customer since, and guess what he gave me? Check it out. Look at it. It's the pollen filter. It's disgusting. There's bugs and twigs and dust. It's had it. It should be replaced. In a recent rant on one of my other videos, I told you about the importance of replacing pollen filters on a regular basis. It's a maintenance thing. They should be done according to the manufacturer's specifications, and here's the reason why. Imagine the stress and strains put on that MOSFET together with those pins being pulled out through the solder due to overheating. You've got to keep up with your maintenance, guys, otherwise you will do more damage in the future. Well, that's me out. Back to you, MiracleMAX. Thanks for watching, guys. If you haven't already, feel free to subscribe to this channel. Make sure that you give it a like and give it a comment down below. Until next time, this is MiracleMAX signing off. Catch you later.